Okay, let's start with the section B in paper 2 of AdMaths. This is question number 7. Now, section B, the questions are very long, longer than the section A. So let's start it right now. Okay, so we have given A and B are two fixed points. Q moves such that we have the ratio of AQ and QB. So in this case, the moving point, so most likely it's a locus question. So yes, show that the equation of the locus of point Q is this. So let's do it. When we want to find the locus, we have to apply the concept of distance. So let's put down the information first. Point A is 5, -2. Point B is 2, 1. And the ratio of AQ is to QB is 2:1. And then from here, let's write this one in terms of equation. We change the ratio form into the fraction form. So AQ over QB equals to 2/1. Now, then we apply the concept of distance. How do we find the AQ in the first place? Now we have the point A, we have the point B. Q, since it's a moving point, so let's just put the general X and general Y. So the formula will be square root of X minus the A, so minus 5 squared plus Y minus the Y minus a -2 become plus 2 equals to, over for the B. So x minus 2 squared plus y minus 1 squared equals to 2/1. Now next, get rid of the square root. So we bring the square root across to the other side, or in another word, we square both sides of the equation. So we will have 4 over here. So over this side, let's expand at the same time. So x squared minus 10x plus 25 plus y squared plus 4y plus 4 equals to, this side is 4. And at the same time, I will expand this as well. It will be x squared minus 4x plus 4, and then plus this one, y squared minus 2y plus 1. Oh, not enough space. Huh? Okay, over here, we will have x squared. Rearrange so that it's tidy. So minus 10x plus 4y plus 4 and 25 plus 29 equals to this one. We also multiply the 4 at the same time. So 4x squared plus the y squared times the 4, 4y squared. Minus 4x times the 4, minus 16x, minus 2y, so we have minus 8y. 4 plus 1 is 5 times 4, we got 20. And let's group them together. Now, over here we have 4x squared and 4y squared. Now, of course, we shall move all these across to the other side. So we will have 3x squared plus 3y squared. Minus 16, bring this over, become minus 6x. And then minus 8y, minus 4y, we have minus 12y. And then plus 20, minus 29, we'll have minus 9 equals to 0. Now let's look at this. All these are multiple of 3, so we can simplify it by dividing both sides with 3. So we will left with x squared plus y squared minus 2x minus 4y and minus 3 equals to 0. Let's compare to the question. It says, show that the equation of the locus is given by x squared plus y squared. So we have x squared plus y squared minus 2x minus 4y minus 3. So we have just shown. That's it. All right. The next part of the question will be show the point. Okay, we need to show that this point lies on the locus of point Q. If this point lies on the locus of point Q, it will satisfy the locus Q. So C is negative 1, 0. Yeah, so we got to show that. So point C, negative 1, 0. This is part B. Okay, if on locus Q, it will satisfy locus Q. So let's start by substituting negative 1, x, and 0 for the y into here. So start from the left-hand side. We will have, whenever we see x, we replace with negative 1. Okay, 0 minus 2 times negative 1 minus 4 times 0 minus 3. Let's see what do we have. Over here is 1. This is 0. No need to write. So negative 2 times negative 1, we will have positive 2. And then this is 0. And then minus 3. 1 plus 2, 3. Minus 3 is 0. Isn't it? It is equivalent to the right-hand side of our equation of locus. Therefore, proven. Okay, ask us to prove, is it? Shown. Okay, then we write shown. We have shown that C is on locus Q. Okay, so done with question B. Now question C. Find the equation of the straight line AC. Okay, we have to find the equation of straight line AC. We know that A is 5, negative 2. C is negative 1, 0. We have to find the equation of the A and the C. So to find equation, we must have two things. One is the gradient of AC. Another one is a point. Now we have 2 points over here. So let's choose one. I will choose C because it's look easier. All right, then how do we find the gradient of MC? So the gradient, we can find first, equals to, or we straight away put in the formula. Okay, or no, never mind, we just do like this. So y2 minus y1. So negative 2 minus 0 over x2 minus x1. 5 minus negative 1. So we will have negative 2 over 6, negative 1 over 3. So with this, we can form the equation that will be y minus y1 equals to m x minus x1, which is positive 1 over here. Now, that's a fraction, so I will try not to write the answer in fraction mode. That's just my personal preference. You can write this in gradient form, is fine. Okay? This is your answer. Okay? Or you can just move the 3 over. So we will have 3y equals to negative x, negative 1. And I write x plus 3y plus 1 equals to 0. This is general form. It's my personal preference. Okay, you can just leave this as your answer. So we have done, that is part C. Now, next, part D. Okay, what is it about part D? Part D say, given that the straight line AC intersect the locus Q again at D. Okay, so we need to find the coordinates of D. Now, if AC intersect at the locus Q, that means we can, so the equation of y, and then the locus of the Q is given just now, x squared plus y squared minus 2x minus 4y minus 3 equals to 0. To find the intersecting point, we have to solve the equation simultaneously, remember? Or we can substitute, then we use the b squared minus 4ac. There's so many ways. So let's use the simultaneous equation. Whenever we see y, we replace over here with negative 1 over 3x minus 1 over 3. Oh, it looks so complicated over here. Intersect. Okay, never mind. We have no choice. So we will have x squared plus negative x over 3 minus 1 over 3 squared minus 2x minus 4 negative x over 3 minus 1 over 3 minus 3. Okay, simplify this one. We will have x squared. Now the negative after you square become positive. Okay, let me do like this. So we'll have plus negative over 3, x plus 1. And this whole thing square. And then minus 2x minus 4. And then this is negative x plus 1. Okay, equals to 0. I just want to simplify the thing so that it looks easier for me to solve later. So over here, when I square the negative, I'll get positive. So I will have x squared plus, expand this one, x squared plus 2x plus 1 down there, 9. Minus 2x, negative, negative become positive. So positive 4 x plus 1 over 3 minus 3 equals to 0. Now you see the fraction mode here. I try to get rid of the fraction mode by multiplying both sides with 9. So I will have 9x squared plus x squared plus 2x plus 1 minus 18x, everything times 8 times 9. And then this one times 9, I will have, after simplify, I got 3. So 4 times 3, 12. 12x plus 12 and then minus 27 equals to 0. Everything times 9 on both sides. Okay. Double check. 18, 27. This one simplified is 3, so 4 times 3 is 12. So 12x plus 12. Okay, so with this, then we can solve. Yeah. So now we have 10x squared over here. And then the 2x minus 18x, we got negative 16x. Negative 16 plus 12, so we have negative 4x. The constant 1 and 12, so 13. 13 minus from the 27, we have negative 14 equals to 0. Now multiple of 2, simplify. So we have 5x squared minus 2x minus 7 equals to 0. So we have to factorize this part. Okay, so how do we factorize? 5x squared minus 2x minus 7, yeah? So 5x squared minus 2x minus 7 equals to 0. So we have to factorize like this lah. What else? Okay, so 7 and 5 like that. Okay, 7 and 5, in which this is negative, this is positive. Oh, sorry, 7 and 1. 7 and 1. Okay, so that 5x times x is 5x squared. Negative 7 times 1 is negative 7. Inner pair is negative 7x. Outer pair is 5x. The sum will give us negative 2x. Therefore, our x equals to 7 over 5. Or x equals to negative 1. Now, just now we have found our C. Oh no, C is given. So this is the x coordinate of C. Because AC passing through the locus. AC passing through the locus at 2 points. Yeah? Alright. That is, one is C, one is on D. So this is for the C. This is from coordinate C. It's a coordinate of C. All right, so we just focus on this. Therefore, from which equation? From the equation of the y, because this straight line also passing through the D, right? So negative 1 over 3x minus 1 over 3. So substitute in there. So from which equation? Oh, okay. From y equals to negative 1 over 3x minus 1 over 3. So we will have, whenever I see x, I replace with 7 over 5 minus 1 over 3. So this one you can use the calculator, right, and get the answer right away. So we will have negative 1 over 3 times 7 over 5, and then we minus 1 over 3. So we have negative 4 over 5 as our answer. Therefore, the coordinates of D will be 7 over 5 and negative 4 over 5. That's it. Okay? So we have found D right away. Done with question 7.